YC Mathematics and Physics, University Calculus, Lesson 10, Chain Rule. Before we start chain rule, we need to go back to the label of derivative. Okay. We need to go back to lesson 1. In lesson 1, we use this label, y prime represents derivative y prime represents the derivative of the given function of y. Now we introduce another label. Now we introduce another label, dy dx, to represent the derivative. Now, the y is the variable on the left side of the equal sign. On the left side of the equal sign. What is x? X is a variable on the right side of the equal sign. So let's have an example. So example, y equals 2 minus 3x. You see, this y is a variable on the left side of the equal sign. X is a variable on the right-hand side of the equal sign. Now, what is the derivative? We use this label, y prime. And if you do the derivative, you know the result, which is -3. That's a label we used before. Now we use a new label, dy dx. Then this represents the derivative, which is also -2. In other words, a -3. Sorry, I made a serious mistake. The derivative is -3. The derivative is -3. In other words, this label and this label are the same. Okay. This label is called prime label, prime notation. The reason is very simple, because I have a prime there, so it's prime notation. This label is called Leibniz notation. This is a mathematician who contributed to calculus in the early years. So we use his name. There is another spelling which is equivalent. Libnitz. So these two spellings represent the same person. So different books may use different spelling. Okay. When you read this, when you pronounce this, you said y prime. How do you pronounce this? This you pronounce dy by dx. That's how you pronounce it. Do not pronounce dy over dx. Don't do that. And neither you say dy divided by dx. So don't say this way, nor to say this way. Okay, but this is a proper way of pronounce this dy by dx. This is by. Okay, it's a very special label. So let's have another example. Rho equals 2 over theta plus 1. We know how to do the derivative from previous lessons. And the result is the derivative is this. That's a derivative. That's a prime notation. But we can also use the Leibniz notation. Then we write it's the same thing, okay? Prime notation, Leibniz notation, it's the same thing. But remember, rho is a variable on the left-hand side of the equal sign. You see here? Rho is a variable on the left-hand side. Theta is a variable on the right-hand side of the equal sign. So that's how you write your notation. Let's now go to chain rule. Another example. I give you two functions. The first function is y equals 2v over 1 minus v squared. And what is v? V is 1 minus x squared. So there are two functions there. Look, y is a function of v, but v is a function of x. So y is a function of x. Do you get it? Okay. Because you can substitute 1 minus x squared into this v and also into this v. And the result, on the right-hand side, you have x. On the left-hand side, you have y. Therefore, eventually, after you substitute, y is a function of x. So we need to find, because y is a function of x, I want to find dy by dx. In this case, it is not too clear if you write y prime, because y prime, although it represents the derivative, it doesn't tell you which variable is on the right-hand side, which variable is on the left-hand side. It doesn't tell you that much. This is much clearer, because eventually the variable on the left-hand side is y, and after you do the substitution into here, the right-hand side has a variable x, so you can find dy by dx. Now, how do you do that? So we use a formula. Use a formula to find it. What formulas? This is the formula. Dy by dx is equal to dy by dv multiply dv by dx. So this is a formula. All right. And this formula is called a chain rule. So we just do the derivative of y with respect to v. So that means we know we need to do the derivative of this function. And we do the derivative of v with respect to x. It's here. Do this derivative. And you multiply the two derivatives. The result is dy by dx. So let's do that. Okay. First, I want dy by dv. Dy by dv is just the quotient rule, right? Remember the quotient rule. Remember the quotient rule. Quotient rule is u, this is v, u prime v. U prime is 2. V is 1 minus v squared. This is u prime v. Then minus v prime u, minus this, the derivative of this, which is negative 2v. Okay. The derivative of this multiplies the top. So u prime v minus v prime u divided by v squared. Divided by v squared. This is the quotient rule. Now, I am not going to write the detailed steps. You expand the top, 2 here, minus 2v squared, right? 2 minus 2v squared. And here, negative becomes positive, plus 4v squared. So what do we have now? If you simplify your numerator, the result is 2 plus 2v squared. And the denominator is 1 minus v squared. And the whole thing squared. So this is dy by dv. Now I have this. I need to find dv by dx. So this is the derivative of this function. So dv by dx. So this is easy, minus 2x. Minus 2x. Then, we use a formula. What is dy by dx? dy by dx is this, dy by dv multiply dv by dx. So I have dy by dx is equal to this. Multiply negative 2v, negative 2x. So this is my derivative dy by dx. And what is the result? If you multiply, then you get negative 4x bracket 1 plus v squared, and the denominator is now this is my result, dy by dx, by using the chain rule. You will notice that on the right-hand side, you not only have the variable x, you also have the variable v. But this is all right. This is your answer. Okay, this is your answer. So don't worry about you have two variables. This is your answer. Now, you wonder, I already mentioned why y is finally a function of x. Because I can substitute v into this v here and into that v there. Then finally, the right-hand side is only x, the variable x. So I can do dy by dx after I substitute. And this is what we're going to try the next. Another way, in other words, I have another way of doing it. So by substitution, okay. So now y equals 2v 1 minus v squared. And I substitute the second equation into this. So I have 2, 1 minus x squared. That's my v. And 1 minus, I substitute v. So substitute into it. And then you do this. Expand this. Expand the numerator, and expand this square, and then combine with here, 1 minus this. So you simplify this. So I'm not going to show you the detail of this, but you can do that, of course. So the result of doing that is this. Then, you see, y is a function of x. Therefore, you can find the derivative. This is a quotient. You do the quotient rule. Right? You do the quotient rule. It's very long. It's very long. So the bottom is the square of this. So you have that. The top is u prime times v minus v prime times u. So you have u prime times v u prime v minus v prime u. This is v prime u. You see, the numerator is quite long, quite complicated. So let's expand the numerator. So I have so just expand it. So you expand it. See this? 2 times 4 is 8 minus 8 x power 3. Minus minus is plus. So plus 4 x here, x to the power 4. So together is x to the power 5. Now here, 2 times 4 is 8. 8x. 8x with a minus sign. And this times that is 8x cubed. So minus minus is plus, 8x cubed. This times that is 8x cubed, minus minus is plus. And this times that is 8x to the power 5, minus minus is plus, but you have a minus here, so you have a minus. So let's just repeat the denominator. Yeah, okay. So you simplify the top now. So this minus 8x cubed, and I have a plus 8x cubed, so that can be cancelled. Then I still have 8x cubed. I have x to the power 5, x to the power 5. So I have minus 4x to the power 5. Correct? This is plus 4. This is minus 8. So I have minus 4x to the power 5. And then power 3. Power 3 is this. And then power 1 is minus 8x. That's all I have from the numerator. And the denominator, you don't need to expand the denominator, okay? So I have this result. Let's compare this result with the result I have before using chain rule. This is substitution, you get the result. And if I use chain rule, I get this result. So are they the same? Of course they are the same. It doesn't look like they are the same because here you have v and v, but here you have everything in x. So how do I show they are the same? I need to substitute v into here and then compare whether this is the same as that. And you do that. I think I should leave this as an exercise to you. So you substitute v into here. The v is, oh, here, you already have it here. What is v? V is this. V is 1 minus x squared. So you put 1 minus x squared here. Put 1 minus x squared here. And simplify. Of course, it's very long, right? It's very long. Be patient, be careful, and you expand it and simplify, you get the same result as this one. So substitute v into here and here, simplify, and you compare whether, no, I'm sorry, I'm pointing at the wrong thing. Substitute v into here, and simplify everything, and then you compare this result with this. And it turns out they are exactly the same. And you will see that if I do not mind to have two variables on my right-hand side, then the chain rule is much shorter. And if you do the substitution and then do the derivative, it's much longer. So chain rule is all right. Although you have two variables on the right-hand side, it is perfectly correct. All right, so the conclusion is chain rule is shorter and simpler. Okay. I need to discuss something here. The chain rule. We need to go back to lesson 4. Go to lesson 4. Lesson 4 is about general power rule. General power rule. Let me repeat what the general power rule is. The general power rule says if y is v to the power n, then the general power rule says the derivative is n v n minus 1 times the derivative of v. Now, let's review the general power rule. Have an example. So y is this, and you want to find the y prime. Which means find the derivative, all right? Now, how do we do that? This is already done in lesson 4, but we are repeating it. So you rewrite it. Y is equal to the square root (1 minus 2x), but the square root can be written as an exponent. Then you call this v. So v, right? So where I use v to represent 1 minus 2x. Now, use the formula. So what is y prime? So y prime is n 1 over 2. V, this minus 1 times v prime. That's the general power rule. And then I see this v becomes negative 1/2. V prime is the derivative of v. What is the derivative of v? V is 1 minus 2x. Therefore, the derivative is just a negative 2. So if you simplify this, 2 and 2 cancels, you have a negative. And then this is negative 1/2 power. So you have this. And you can put this v to the half, v to the 1 minus 2x. So this is your result. So this is lesson 4. Now, you look at this. What is this? This is the derivative of this, right? The derivative of this. So this is my dy by dv. You see, y is a function of v. If I do the derivative of y with respect to v, I get this, right? There is no this part. This part is dy by dv. So what is this part? This part is dv by dx. So you see, dy by dv times dv by dx is dy by dx. So this is exactly the chain rule. So this is chain rule. So the general power rule is nothing but our chain rule. So chain rule is more general, okay? We are using chain rule, but without pointing out its chain rule when we do the general power rule. So this is my discussion. Okay. So the next, we can do some practice now. So let's have some practice. The question is, so question 1, y is equal to u to the power 6. And u is 1 plus 2 square root x. And question number 2, so y is square root 2u minus u squared. And what is u? U is x squared minus x. Okay, question 3. Y is a minus u divided by a plus u. And what is u? U is b minus x divided by b plus x. So next, question number 4. Y is equal to u times the square root a squared minus u squared. And what is u? U is square root 1 minus x squared. And I'm going to give you the answer. So for question number 1, it is, let's see. I didn't write it clearly. Okay, 6 U5. You see, I am using chain rule, so the right-hand side contains 2 variables, u and x. But it doesn't matter, right? It doesn't matter. Again, the right-hand side contains 2 variables, u and x. For question 3, the answer contains also 2 variables, u and x. Question 4, the answer to question 4 also contains 2 variables, x and u, because we are using the chain rule. Okay, so this is practice. Let's make a summary. What we have in today's lesson. So today's lesson is about chain rule. Okay, let us write down the chain rule. If the function y is written as function of v, if this means y is a function of v, and this means v is a function of x. So y is a function of v, and v is a function of x. Then the derivative of y with respect to x is equal to what? Is equal to the product of the derivative of y with respect to v by the derivative of v with respect to x. So the chain rule says you have y as a function of v, and v is a function of x. So what is the derivative of y with respect to x? It is a product of the derivative of y with respect to v by the derivative of v with respect to x. So you multiply these two derivatives and you get the final answer. So next, I want to write down the chain rule. This is my chain rule. Look, it is a very special rule. You look at dy by dv and dv by dx. It looks like a fraction, right? It looks like a fraction. If it is really a fraction, then dv and dv can be cancelled. So let's suppose it is a fraction, then you cancel dv and dv, then you get dy by dx. This is how you remember the chain rule in a very simple way. So it looks like this and this can be cancelled. But this is important. It is important to note that dy by dx is not a fraction. This is very important. It looks like a fraction. It is actually not a fraction. But if it were fraction, then you can cancel this, and then you get the chain rule. This is how you memorize the chain rule. But the important thing to note is that it is not a fraction. Or maybe this is somewhat confusing to you, but don't worry. Don't worry. We will discuss things similar to that later on. So this is our lesson. I think it's lesson 10, right? Yeah, this is lesson 10. So this is the end of lesson 10. And as before, I like to remind you that call this number. Oh my, I made a mistake very often. Call this number, talk to me. That's my name. If you have any questions, and if you want to discuss something, just call this number and talk to me. Actually, I like you very much to join my program, and you learn from me. I will give you lessons. In this pandemic, the lesson will be one-on-one, online. And your practice, you will hand in to me, and I will correct it question by question, and I will discuss the questions with you one-on-one, online. Don't forget to call me by this number. Goodbye. See you next week. No, not next week. Sorry. See you next time.